Somewhere in the rivers of the Amazon, a fish is hunting. It can't rely on sight. The water is too dark, too murky, too full of silt and shadow. It can't chase. It's not built for speed. It doesn't have claws or venom or teeth worth mentioning. What it has is significantly more unsettling. It has a remote control. Meet the electric eel, which is, first things first, not actually an eel. It's a knife fish, more closely related to catfish and carp than to true eels. But electric knife fish didn't test as well apparently, so electric eel it is. It can grow up to 2.5 meters long. It breathes air. It has to surface every few minutes or it drowns, which is a strange sentence to write about a fish. It has terrible eyesight, and roughly 80% of its body is one single enormous specialized organ. That organ produces electricity. Here's how it works. Inside the electric eel's body are 3 electric organs made up of thousands of modified muscle cells called electrocytes. Think of each electrocyte as a tiny biological battery. On its own, barely a flicker. But stack 6,000 of them in sequence, all firing simultaneously, you get up to 860 volts. For context, a standard wall socket in Australia runs at 230 volts. The electric eel hits nearly 4 times that. It is, by a significant margin, the most powerful living bioelectrical generator on Earth. Now, you might assume the electric eel uses this power the obvious way. Swim up to prey, zap it, eat it. And yes, it does that. But scientists recently discovered something far more interesting happening first. Something that, if you stop to think about it, is one of the most sophisticated hunting techniques in the entire animal kingdom. The eel doesn't just shock its prey, it remote controls them. Here's what actually happens. A small fish is hiding. Maybe it's tucked under a rock, or buried in the silt, or perfectly still in a patch of weeds, doing everything right, evolutionarily speaking. Completely invisible. Safe. The electric eel emits a low-voltage pulse. Not the big hunting shock, something much smaller. A doublet. 2 rapid pulses fired in quick succession. These pulses travel through the water and hit the hidden fish's body. And here's where it gets extraordinary. The electric field doesn't just touch the fish, it penetrates it. It reaches the fish's own motor neurons, the nerve fibers that control its muscles, and it fires them, involuntarily, without the fish's brain being involved in the decision at all. Every muscle in the fish's body contracts simultaneously. The fish twitches. Not a big dramatic convulsion, just a twitch. A single involuntary full-body flinch that the fish has absolutely no control over and no warning of. But that twitch moves. Water. And the electric eel, which has electroreceptors running along its entire body, feels that movement with extraordinary precision. The hiding spot is revealed. Then comes the real shock. The eel fires its high-voltage discharge, the full hunting pulse, and this time, it's targeted. The prey fish's muscles contract so violently and so completely that the fish is immobilized. It cannot swim, it cannot escape. It is frozen in place by its own nervous system being commandeered from the outside. The eel closes in and swallows it whole. Total time from first pulse to capture, milliseconds. This was discovered by biologist Kenneth Catania at Vanderbilt University, who spent years filming electric eels in slow motion and measuring the electrical pulses with extraordinary precision. What he found changed how scientists understood predator-prey relationships entirely. The eel isn't just a living battery, it's running a 2-phase operation. Phase 1, reconnaissance. Low-voltage doublet pulse. Force a twitch, locate the target. Phase 2, strike. High-voltage discharge. Immobilize, consume. It's not brute force, it's strategy. But it gets more sophisticated still. When electric eels attack larger or more difficult prey, something that might struggle or escape, they curl their body into a C shape, sandwiching the prey between 2 points of their electric organ. This doubles the voltage passing through the target. The eel has worked out, through millions of years of evolution, that it can intensify its own electric field by changing its geometry. It's using physics. A fish using physics in real time while hunting. Electric eels also use electricity for things other than hunting. They use low-voltage pulses constantly, like a sonar ping, to navigate murky water, to detect objects, and to communicate with others. Electric eels. Each individual has a slightly different pulse signature, like an electrical fingerprint. They can tell each other apart by their electricity. They also, and this is not a joke, use their voltage to deter larger predators. A full 860-volt discharge will discourage most things that might consider eating an electric eel. There are accounts of electric eels leaping partially out of the water to deliver shocks to threats above the surface, pressing their chin against a predator to maximize contact and intensify the charge. They are not prey. They are extremely aware of this. To understand how remarkable 860 volts from a living creature is, researchers studying electric eels in the field report that simply reaching into a tank, not touching the eel, just putting a hand in the water nearby, is enough to feel the pulses as a sharp, unpleasant jolt up the arm. The eel doesn't have to touch you, the water is enough. The electric eel evolved this system over millions of years in one of the most competitive, predator-dense ecosystems on Earth, the Amazon basin. In an environment where visibility is nearly zero and every species is either hunting or being hunted, it developed a solution that no other animal on the planet uses in quite the same way. It removed the need to see its prey. It removed the need to chase its prey. It removed the prey's ability to hide, to run, or to make any decision about what happens next. The electric eel doesn't find its prey. It makes its prey find itself. Somewhere in the dark water of the Amazon right now, a small fish is hiding perfectly, completely still, completely invisible. It has no idea there's an eel nearby. It has no idea that in approximately 1 second, its own muscles are going to betray it. And there is nothing, not one single thing it can do about that. That's Zoodoodle, nature. Doesn't play fair. It doesn't have to.